Hello, hello, hello. We are back with Chapter 11, Multi-Step Equations and Inequalities, focusing on Lesson 3, solving equations with variables on both sides. So for these problems, we're going to solve the equations and we're going to check your answer. So we're going to go over how to do the check with these particular types of problems. So I want to do the first couple together just so we're able to kind of go over the checks. And you're able to kind of see how that works out. So first, before we can do the check, we have to solve the problem. So let's go ahead and let's look at this first one, number 1. And what I notice is that the equal sign always splits an equation into two sides. So I'm noticing that I see a 9p variable on this side and also a variable on the other side of the equation. So remember, whenever there's variables on two sides of the equation, we look at the coefficient, and whichever one has the lesser coefficient, that's the one we're going to move. So the coefficient of 9p is 9. It's the number in front of the p. And the coefficient of 6p is just 6. So which number is less, 9 or 6? And 6 is lesser. So that is the one that we're going to move. So we have to use our inverse operations. So this is a positive 6p. So the inverse of a 6p would be negative 6p to both sides. Okay, a positive 6p minus 6p, that cancels out and becomes 0. So all we're left with on this side of the equation is 21. Then we're doing 9p minus 6p, and that's really the same thing as 9 minus 6, which is 3, and then you just put a p on the end of it. Okay, so we're trying to figure out what p equals. So we need to get p by itself, and this is 3 times p, and the inverse operation of multiplication is division, so we're dividing both sides by 3. 3 divided by 3 is 1. 1 times p is p. So we're left with p equals 21 divided by 3, which is, yes, it's 7. 3 goes into 21 7 times. So our answer is p equals 7. But we're going to go ahead and check this. So I'm going to write the word check. I'm going to write the original equation. 9p equals 6p plus 21. I'm going to double check to make sure that I wrote down everything, all the signs correctly, which I did. Now, we're going to check it. P equals 7. So that means everywhere I see a P, so there's a P here and then there's a P there, I'm going to input a 7. I'm going to substitute a 7 in there. So 9P is the same thing as 9 times P. So when I substitute 7 in there, it's the same thing as 9 times 7 equals 6P, which is 6 times 7, plus 21. So here, there are two sides of the check. There's this side, and then there's this side over here. And I'm going to work both sides, each side independently. So 9 times 7 is 63 equals, and then over here I have multiplication and addition. So I'm going to follow the order of operations, which states that I need to do the multiplication first. So 6 times 7 is 42. Plus 21. Now I'm going to do the addition, but I'm going to come over here to the side of my paper and go 42 plus 21. 2 plus 1 is 3. 4 plus 2 is 6. And so this equals 63. So we have 63 equaling 63. That is a true statement, which means our solution right here, P equals 7, is the solution to the original equation. So that's kind of how a check works. You write it down, you substitute the number in, and then you just work each side of the equation independently. You don't move anything from side to side in the check. You just keep working it down. That's really, 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 really key. Okay, let's go ahead and work on number 2 together. So I locate the equal sign. It's right there. Here's one side of the equation. Here's the other. I notice immediately that I have a variable on this side and then another variable on this side of the equation. So I have variables on both sides of the equation. So I'm going to look and locate the variable that has the lesser coefficient. So the coefficient here is negative 5. The coefficient here is a positive 2. Well, I always know that a negative number is less than a positive number. So this would be the lesser coefficient. This is the smaller variable, so I'm going to use my inverse operations to move this variable to the other side of the equation. So this is a negative 5t, so the inverse operation of that would be a positive 5t. To both sides, Negative 5t plus 5t is 0. That cancels out. I'm left with negative 14 here. 2t plus 5t is just the same thing as 2 plus 5, which is 7t. Okay? Now I have t right here. I'm trying to get t by itself. It's 7t. So this is 7 multiplied by t. I got to do the inverse operation of multiplication, which is division. I'm dividing both sides by 7. 7 divided by 7 is 1. 1 times t is just t. Now I have t by itself. Negative 14 divided by 7. I'm going to do the signs first. So negative divided by a positive is a negative. And then 14 divided by 7 is 2. So the answer is negative 2 equals t, or I'm going to write it like this. T equals negative 2. All right, great. Now we're going to do the check. Okay, so I'm going to write the original equation. Negative 5t minus 14 equals 2t. Okay, and I'm going to substitute this negative 2 in for the t here and also in for the t here. Now it's a negative number, and this t has a coefficient, so that means I have to put it in parentheses. So this is going to be a negative 5 times negative 2 minus 14 equals 2 times the t is negative 2, right there. Okay? So I have this side of the equation and I have this other side of the equation. I'm not moving anything. I'm just using my order of operations, and I'm going to work down. I'm going to solve this side of the equation and simplify it. So here I have a negative 5 times a negative 2 minus 14. So order of operations state that I have to do the multiplication first. So I have a negative 5 times negative 2. I'm going to figure out the signs first. So a negative times a negative is a positive. 5 times 2 is 10. So I have 10 take away 14 equals, and then I can do this, right? 2 times negative 2. Well, I'm going to do the signs. This is a positive times a negative. A positive times a negative is a negative. 2 times 2 is 4. Okay, perfect. I'm going to continue to work on this side. I have a positive 10 minus 14, which is the same thing as a negative 14. So I have a positive and I have a negative, and they're, they're being subtracted by each other. So whenever the signs are different, this is a positive and a negative, you take the difference. So the difference between 14 and 10 is actually equal to 4. And then I look at these numbers regardless of the signs. Okay, which number is bigger? 14 is bigger and 14 is negative. So that means this is going to be a negative 4 equals negative 4, which is a true statement. Which means that my answer, t equals negative 2, is the solution to the original equation. Okay, we're going to do one more problem together just because I really want to go over these checks when there's variables on both sides. And then I'm going to have you do these problems down here. So let's look here. We have 2k equals 18 minus 4k. And remember, whatever I'm writing, you need to be writing. Okay, so I'm finding the equal sign. That divides the equation into two sides. I see a 2k here. There's a variable there, and then there's a variable over here. Okay, now I'm looking at 2k, and I'm looking at negative 4k, and I'm looking at the coefficients. Which one has the lesser coefficient? So we have 2 and negative 4, and negative 4 is less than 2. So that's the lesser coefficient. And so I'm going to do the inverse operation of minus 4k, which would be adding 4k to both sides. Okay, so negative 4k plus 4k, that's going to cancel out and become 0. Then I have 18 here. Then 2k plus 4k would be 2 plus 4 is 6k. And then I'm trying to get k by itself. Okay, so I have to get rid of the 6. The 6 is related to k through multiplication, so I have to do the inverse operation of multiplication, which would be division. So I'm dividing both sides by 6. 6 divided by 6 is 1, and 1 times k is k, so now k is by itself. 18 divided by 6 is actually equal to 3. So my answer is k equals 3. Okay, let's go ahead and check it. So I'm going to write the word check. I'm going to write my original equation, 2k equals 18 minus 4k. And please notice that there's a K here on this side, and there's also a K over here on this side. So I'm going to substitute K equals 3 in for this K and 3 in for that K, both of these sides of the equation. So 2 times 3 equals 18 minus 4 times 3. Okay? And I'm just going to solve each side of the equation independently using my order of operations. I'm not moving anything from side to side. Okay? So 2 times 3 is 6 equals, I have 18 minus 4 times 3. So I have subtraction and multiplication. I'm going to do the multiplication first. So negative 4 times 3. I'm going to do the signs first. I'm going to rewrite this 18 first. Okay, so negative times a positive is going to be a negative, and 4 times 3 is 12. Okay? Now this 6 is already simplified. I can't do anything else there, so I'm just going to rewrite that. And now I have 18 minus 12, and 18 minus 12 is 8 minus 2 is 6. 1 minus 1 is 0, so it's 6. So this is a true statement, which means that the answer that we found right here is the solution to the original equation. So, yeah. Okay, now it is your turn. I want you to try 4, 5, and 6. Okay, so go ahead and I want you to work the problems out and then do the checks, write the original equation, write the word check, solve them all out when you get done. So go ahead and pause. When you get done with those, press play and we'll see how you did. All right, see you in a bit. See you in a bit. All right, we're back. So let's look at these problems. So the equation sign splits the equation into two sides. What I notice is I have variables on both sides, negative 6u and positive 6u. So I'm looking and I'm trying to find, well, which one is the lesser coefficient? And remember, negative 6 is the coefficient here, 6 is the coefficient there. So negative 6 is definitely the lesser coefficient. Okay, so that's the one I'm going to move. So I'm going to do the inverse operation of this negative. Okay, so I know that this is related to the 48 through addition. And the inverse operation would be subtraction, but this is a negative, and so I'm actually going to do the inverse of the negative, which would be addition, because at the end of it, I'm really trying to get this to equal 0. Negative 6u plus 6u equals 0. If I had negative 6u minus 6u, that would equal negative 12u, and so that wouldn't equal 0, so that wouldn't help me at all. So this one's a little tricky. You know that you see this little addition sign right there, so that just tells you that you're going to be doing either addition or subtraction as the inverse operation. Okay, so it's going to be one of those two, and then you look at this number and you say, hey, it's actually a negative number, therefore the inverse is going to have to be addition, and that's why we're adding the 6u to both sides of the equation sign. Okay? Oh, whoops. Very good. You didn't really see that. Okay. So yeah, so negative 6u plus 6u, they cancel each other out, and that's 0. And that's what we want, because what we're trying to do is get the u's on the same side of the equation, right? And so all we have over here is 48 equals 6u plus 6u is the same thing as 6 plus 6, which is 12u. Okay, we're trying to get u by itself. It's 12u. Which is 12 times u, so the inverse operation is division of multiplication. So we're dividing both sides by 12. And then 48 divided by 12 is 4. So u equals 4. I always like to write the u on the left side. So u equals 4. But now we're going to do the check. Okay, so we're going to write the word check. And then you're going to write the original equation, negative 6u plus 48 equals 6u. So there is a u here, and there's a u here. So we are going to substitute this 4 into both of those places where the u is located. So we have negative 6, substituting 4 in for u, plus 48 equals 6 times 4 again, right there. And we're just going to work each side separately. We're not moving anything from side to side. We're just following our order of operations. So we have multiplication here and addition. So we're going to do the multiplication. We have a negative 6 times 4. So I'm going to figure out the signs first. A negative times a positive is a negative. 6 times 4 is 24 plus 48 equals, and now I'm going to work on this side. 6 times 4 is 24. Okay, now I'm going back to this side. I got a negative 24 plus 48. Okay, so I'm adding, and I have a negative and a positive, so the signs are different. So I'm going to take the difference of the two numbers. So I'm going to go 48 minus 24 here. Figure out what the difference between these two numbers are. 8 take away 4 is 4. 4 take away 2 is 2. So the difference between these numbers is 24. Now I'm going to figure out, is it a positive 24 or a negative 24? So I look at the numbers independent of their signs. I don't care about the signs at this point. Which number is bigger, 48 or 24? Well, 48 is a bigger number, and 48 is positive, so that means my answer is going to be positive. So it's 24, and then I drop this 24 over here, and they're equal to each other. It's a true statement, which means that this is the solution to the original equation. So if you got that one right, great job. On to problem number 5. Here we go. So we have 7m minus 25 equals 2. So we're looking at this equation sign that splits it into two sides, the equation into two sides. I notice that I have a 7m on this side of the equation and a 2m on the other side of the equation. So I'm trying to figure out, well, what's the lesser coefficient between the two? And I know that 2 is less than 7, so that is the one that I'm going to be moving. Okay, so there's really nothing else over here, so I'm just going to do the inverse of a positive number, which would be a negative number. So I'm going to subtract 2m to both sides. Okay, and what happens when I have a positive 2n minus a 2m? Well, we know that that equals 0, and that's okay. I'm just going to write equals 0. Okay, you can write 0. It's totally fine. Then over here, I have 7m minus 2m, which is 5m minus 25. I'm just bringing that down. Okay, now I'm trying to get m by itself, but it's a two-step, and so I know that I have to keep this 5m together. Okay, so I'm getting rid of this negative 25. So I'm going to add 25. The inverse of a negative is a positive, so I'm going to add 25 to both sides. Negative 25, positive 25 cancel each other out. I'm left with 5n equals 0 plus 25 is just 25. Okay, I'm still trying to get m by itself. So I have 5m, which is 5 times m. So I have to do the inverse operation of multiplication, which is division. So I'm dividing both sides by 5. 5 divided by 5 is 1. 1 times m is m. And that leaves me with m equals 25 divided by 5, which is 5. So I have m equals 5. That's my solution, but I'm not done because I have to check it. So I write the word check. I write the original equation, 7m minus 25 equals 2m. And m is in two locations, right there and right there. So I need to make sure I substitute that 5 in here and also substitute that 5 in to that m as well. So I'm going to do that. I have 7 times 5 minus 25 equals 2 times 5, okay? And I'm just going to work each sides of these equations separately. So I have multiplication and subtraction. So I'm going to do order of operations says I have to do the multiplication first. So I'm going to go 7 times 5, which is 35, minus 25 equals, and now I'm going to do this multiplication over here. 2 times 5 is 10. I'm not moving anything. I'm just going to simplify this right here. 35 minus 25. Well, if I do that on the side, 35 minus 25, 5 take away 5 is 0. 3 take away 2 is 1. That is 10 equaling 10, which is a true statement, which means that my answer right here, m equals 5, is the solution to the original equation. So if you got that right, great job. Okay, on to problem number 6. Okay. I'm locating the equal sign. It's right there. I see that there's variables. Now I want you guys to all take a deep breath. In and out. And in and out. And in and out. And yes, there are fractions, but you can do it. Okay, the dragon, he needs to take a breath in. A breath in and out. and in and out and in and out. You guys can do this, okay? So let's put on our big boy and big girl pants, and we're going for it. So 5/9 in and 4/9 in. Those are my two variables. They're on two different sides of the equation, so we need to get them on the same side. So what we have to do is identify the one with the lesser coefficient. So when I look at 5/9 and 4/9, they have the same denominator, so that's really nice because now I can compare them. And I know that 5/9 is actually bigger than 4/9, which means that 4/9 is the lesser one. So that's the one I'm going to be moving over here to this side of the equation using my inverse operations so that my variables can be on the same side. So I have 4/9a. I need to move it. How is it related to the 6? It's related through addition, so I need to do the inverse operation, which would be subtracting. I'm going to subtract 4/9a to both sides of the equation like so. Perfect. So let's simplify this. I have 4/9a minus 4/9a. So I have a positive and negative. It's the same number. They're going to cancel each other out. That's going to equal 0. And then that equals 6. And then 5/9 minus 4/9. The great thing about this is they have a common denominator. So really I'm just going 5 minus 4, which is 1/9. I keep that denominator and I put that a on it. So 5/9a minus 4/9a is the same thing as 1/9a. Whew, okay, I'm still trying to figure out what a is. Okay, so I got to get it by itself. It's not quite by itself. It's 1/9 times a, okay, but for this one, remember, there is a fraction. So whenever you have a fraction multiplied by a, you're going to multiply by the reciprocal. Reciprocal. So the reciprocal of 1/9 is the same thing as 9 over 1, or just 9, right? So I'm going to do that to both sides. 9 over 1 is the same thing as 9, so I'm just going to multiply both sides by 9. Okay, the cool thing about this is that whenever you look to multiply fractions, you look to cross cancel first and then multiply across, right? So these 9s, they cancel out. They have a common factor of 9 and they become 1, and then 1, all this is 1 times a, which is just a, and now we have a by itself. And then 6 times 9 is the same thing as 54. So there's our answer right there. But we're not done because we have to check it. So we're going to check it. It has fractions and we can still do it, okay? Just keep breathing, okay? Write the word check, write the original equation. 5/9 a equals 6 plus 4/9 a. Okay, there is an a here, and there's also an a there, so that's where we're going to put the number 54 into both places. Okay, so I'm going to write 5/9, and then 5, this is 5/9 times a, and so I'm going to write times 54 equals 6 plus 4/9, and a is 54, so times 54. Okay, and I'm just gonna multiply these fractions. I'm gonna make 54 a fraction, which is 54 over 1. I'm gonna do that in both places. And I'm just gonna work on this side of the equation. So whenever we're multiplying fractions, we first look to cross cancel. So are there any common factors between 9 and 54? The answer is yes. 9 goes into 9, and it also goes into 54. So 9 goes into 9 one time, and 9 goes into 54 6 times, okay? Are there any common factors between 1 and 5? Well, it has a 1, so you can't really simplify that any further. So now it's time to multiply across. So 5 times 6 is 30, and 1 times 1 is just 1. All right, cool. So now we're going to move on to this other side of the equation here. So we have 6 plus 4/9 times 54 over 1. And for this problem, we have to, order of operations says we have to do the multiplication first before we can add. So we are multiplying fractions, so we're going to look to cross cancel. Can we do anything here with the 4 and 1? No. What about the 9 and the 54? Well, yeah, 9 and 54 have a common factor of 9. 9 goes into 9 one time, and 9 goes into 54 6 times. So I can just, now I've cross canceled, so I can multiply across. I'm rewriting that 6 plus right there. So we have 4 times 6, which is 24, over 1 times 1, which is just 1. All right, cool. So 30 divided by 1 is just the same thing as 30 equals 6 plus 24 divided by 1 is just 24. So cool. Now we just have 6 plus 24, which is the same thing as 30. So we have 30 equals 30, which is a true statement, which means our answer right here, a equals 54, is the solution to the original equation. So if you got that one right, yokerekimashita. You did a great job. Okay, on to the next problems over here. We have problems 7, 8, and 9, and I want you to go ahead and work on those, and I also want you to check your answer, okay? So go ahead, pause, work on 7, 8, 9, then press play, and we'll see how you did. See you in a bit. Okay, we're back. We're doing number 7, 8n equals 6n minus 14. So I'm locating the equal sign. That identifies both sides of the equation. I have an 8n on this side and a 6n on that side. So I have to move the variable, since I have variables on the two different sides, I have to move the variable with the lesser coefficient, which in this case would be 6n. So I'm going to move this 6n to the other side. To do that, I have to do the inverse operation. So I have to know, how is 6n related to this 14? Well, it's related to the 14 through subtraction. And what that tells me is that since it's related through subtraction, I'm really going to be either doing addition or subtraction. And it really depends on what this number is. Is this number a positive number or is it a negative number? And what I see is that this is a positive number, which means the inverse operation that I'm going to be using is going to be a negative 6n. Because what we're trying to do, you have to think about it. We are trying to move the n from this side of the equation to the other side of the equation. And in order to move it, we need this to cancel out and become 0. So the only way you can get this to be 0 is if you have a positive 6n subtracted by 6n, then that becomes 0, and we did it to both sides. And now the n is no longer on this side of the equation. All we have on this side is 14. So we did our job. We moved the n from this side of the equation over here. And then we just need to combine these two. So 8n minus 6n is really the same thing as 8 minus 6, which is 2, and then you put an n on the back of it. And we're trying to figure out what n is. So n isn't by itself. This is 2n, which is 2 times n. So we have to do the inverse operation, which is dividing by 2 to both sides. So 2 divided by 2 is 1. 1 times n is n equals negative 14 divided by 2. This is a negative divided by a positive, so I'm going to do the signs first. A negative divided by a positive is a negative. 14 divided by 2 is 7. So the answer is n equals negative 7. Okay, but we're not done. We're going to check our answer, so I want you to write the word check. You're going to go ahead and write that original equation. 8n equals 6n minus 14. Okay, so n is in 2 different locations, so we have to make sure that we put that negative 7 in, substitute it into the equation where the n is. And it's a negative, so we have to make sure we use parentheses. So 8 times negative 7 equals 6 times negative 7 minus 14. Okay, so here there's 2 sides of the equation, so we're just going to work each side of the equation independently. We're not moving anything side to side on the check portion. But over here, when we solve the equation, we move stuff from side to side. But on the check, we're just going to use order of operations to figure out what these mean, and hopefully, if we did it right, they'll equal the same number. So let's start here. We have 8 times negative 7. So let's figure out the signs first. We have a positive times a negative, which is going to be a negative. 8 times 7 is 56, equals, then we have multiplication and subtraction. So order of operations says we have to do the multiplication first. We have 6 times a negative 7. That means it's I'm going to do the signs first. It's a positive times a negative, which means it's going to be a negative. And then 6 times 7 is 42, minus 14. Okay, so this is simplified right here, so I'm just going to write it again, negative 56. This is not, though. We have a negative 42 minus 14. So we have 2 negative numbers that are being, subtracted. So what we're going to do is whenever you're doing this and you have 2 negatives like this, you keep the negative and then you just add 42 plus 14. So I'm going to do that on the side. 42 plus 14 2 plus 4 is 6. 4 plus 1 is 5. So that ends up being negative 56. So it's a true statement. So if you got that right, great job. Our answer is n equals negative 7. That is the solution to this equation right here. Perfect. Okay, on to problem number 8. So in problem number 8, I'm going to go ahead and identify that equal sign. That splits it into two different things, and we have 7 in here. We have a variable on this side, and we also have a variable on the other side. Okay, so we have to move one of them. We're going to move the one with the smaller coefficient, which in this case was 7 and 11. 7 is smaller, and so we're going to go ahead and do the inverse operation to move that 7 in over. So I'm looking at this 7 in, I'm seeing how it's related to 8. It's related to 8 through addition, which means that I'm either going to do addition or subtraction, depending on what this number is. This number is positive, so that means I'm going to do the inverse operation of a positive number, which is a negative number. So I'm going to go minus 7 or subtracted by 7 or negative 7 to both sides. And the reason why I'm doing that is because I want 7 in minus 7 in to equal 0 to cancel out. So there's no longer an n on this side. All I have is 8. Okay, and then I need to do this. 11n minus 7n is the same thing as 11 minus 7, which is 4, and I just put that n on the end. Okay, I'm trying to figure out what n is, so I need to get it by itself. I have 4 times n, which is the same thing. I have to do the inverse operation. The inverse of multiplication would be division, divided by 4 to both sides. 4 divided by 4 is 1. 1 times n is n. And then 8 divided by 4 is 2. And I'm going to switch it because I like having the n on the left side. So n equals 2. That is my answer. So I'm going to go ahead and check it to see if I'm right. So I'm going to write the word check. I'm going to rewrite the original equation. 7n plus 8 equals 11n. And now I have the n in 2 different locations, so that means I need to substitute that 2 in for this n and also in for that n. So we're going to go ahead and do that. So 7 times 2 plus 8 equals 11 times 2. Okay, so I have 2 sides of the equations. I'm going to work them and simplify them independently. So I have multiplication here and I have addition. Order of operations says I have to do the multiplication first. So 7 times 2 is 14 plus 8 equals, I can do the multiplication over here, 11 times 2 is 22. All right, now I'm going to do the addition. 14 plus 8, 4 plus 8 is 12. I write the 2, carry the 1. 1 plus 1 is 2, and that equals 22. So this is a true statement, which means n equals 2 is the solution to the original equation. So if you got the solution and you did the check right, you're doing a great job. Okay, let's move on to number 9. Let's see how you did. Okay, I'm going to locate the equal sign. That splits the equation into 2 sides. I have 2 in here, and I have 3 in here. I have to find the lesser coefficient, and 2 is less than 3. So that's going to have to be the one that I'm going to move. So I'm going to see how this 2n is related to the 8. It's related to the 8 through addition. That means I'm either going to do addition or subtraction, which depends on if this 2n is positive or negative. So 2n is positive, which means I'm going to be doing a negative 2n to both sides. 2n minus 2n is 0, and that's great because that's what I want. I want it to become 0, so I no longer have an n on this side. I've moved all the n's to this side of the equation, which is what I want. 3n minus 2n is just n. 3 minus 2 is 1. 1n is the same thing as n, so I'm just going to write n, and boom, there it is. 8 equals n. I'm going to rewrite it as n equals 8. That is our solution. Now, if you got that right, great, but we have to make sure and check it. So I'm writing the word check. I'm going to write my original equation. 2n plus 8 equals 3n. N is actually right here, and it's right here. So that means I'm going to have to substitute that 8 into 2 places in this equation. So it's going to be 2 times n is equal to 8. 2 times 8 plus 8 equals 3 times 8. Okay? So I'm going to work each side of the equation independently. So I have multiplication and I have addition. So 2 times, I'm going to do the multiplication first. That's what the order of operations states. 2 times 8 is 16 plus 8. equals, and I'm going to work on this side. 3 times 8 is 24. And then I'm going to do the addition. So 16 plus 8. 16 plus 8. Do that on the side. 6 plus 8 is 14. Write the 4. Carry the 1. 1 plus 1 is 2. So 24. So 24 equals 24. That is a true statement, which means the solution here is the solution to the original equation. So if you got all of those right, great job. You are doing wonderful. Okay, let's go ahead and start with 10, 11, and 12.